In this video, I'm going to go through how to find the formula of a hydrate. In this first example, you're given that the hydrated compound is magnesium sulfate, and you're also given that this mass of this hydrated compound is heated until all of the water was removed. And they also give you the mass of the anhydrous magnesium sulfate after it was heated. Now, using this information, you should be able to find the formula of a hydrate. So essentially, the information that you're given is MgSO4, because magnesium sulfate is what you're given. And then remember that in a hydrate, we always put the dot. We always have H2O. In order to find the formula of the hydrate, we have to find the coefficient that we have to place in front of the water. So the information that they've given us so far in this question is that the total mass of this hydrated compound is 5.74 grams. The other piece of information that they've given us is that when all of the water is removed, when you've got just the magnesium sulfate left over, the mass is 2.80 grams. Now, because I know the total mass is this, and that the mass of just the magnesium sulfate is this, I can then, using subtraction, find that the mass of the water in this particular compound is 2.94 grams. So that's my first step, right? Is to find the mass of the water here. Now, after I've done that, I am going to try to find the ratio between the anhydrous portion of this compound as well as the water. So the ratio between those two parts of this compound. In order to do that, we have to find the moles of this as well as the moles of the water. So how do we find moles? Just like we've done previously, you have to find the moles using our molar mass. So 8.0 grams is what you're given of the magnesium sulfate. If I find the molar mass of magnesium sulfate, MgSO4, it is 120.38 grams. I know that this is the mass for every 1 mole of this compound. Now, if the units cancel out, and the number of moles that I have of magnesium sulfate in this compound is 0.023259677. Now let's do the exact same thing for water. So I know the mass of the water, 2.94 grams, and I have to find the moles of it. So for every 1 mole of water, there are 18.02 grams. So if my value of moles of water is 0.163152053. Now, if I'm comparing these two, if I want to find the ratio of these two, I have to divide both of these numbers by the lowest of the two. So the lowest is this. So if I divide this by 0.023259677, this is the same number, which tells me that this is 1. And if I divide this, 0.023259677, the value that I get is 7. So the ratio between the anhydrous portion to the hydrous portion is 1 to 7. That tells me that the value of X here is 7. So the formula of this hydrate is MgSO4, leave the dot there, 7H2O. This is the formula of the hydrated magnesium sulfate. Let's do another example. This is similar, again asking you for the formula of the hydrate. But in this case, we've got a different compound. So it's nickel 2 sulfate. So I have to first identify, let me write this compound out, XH2O. I still have to figure out the value of X, right? That's what I'm solving for. Now, because I'm given the percentage of water in this compound, I'm going to again make the assumption, just like we did in the empirical formula as well as the molecular formula, that the total compound has a mass of 100 grams. Now, if I make that assumption, then I know that the mass of just the water of this compound is 41.1 grams. Now, using subtraction, I can find the mass of the anhydrous portion as well, which is 58 0.9 grams. Now, given this information, the process of finding the formula of the hydrate remains exactly the same as previous. So we start off with our mass. We have to find our moles, right? And we have to do it using our molar mass. So for every 1 mole of nickel sulfate, it weighs 154.76 grams. So the value of moles is 0.380589. And then if I were to do the same for the water, so 41.1 grams times, so the ratio of the molar mass, so 18.02 grams for every 1 mole. Cancel out my grams, and I get 2.280799112 moles. Again, do the same thing. In order to find the ratio between the anhydrous portion to the water portion, I have to divide by the lowest of the two terms, which is 0.380589. Do the same thing on this side. And because this is the same number, I get 1. When I divide these two values, I get 6. So the ratio between the nickel sulfate to the water is 1 to 6. And because I know that, the formula is NiSO4 dot 6H2O. And that's how I figured out the formula of this particular hydrate.